La la la. Where'd I go? That's me, I guess. Computer? Can you handle it? Hi, this is funny. Sorry, I'm trying to figure out how I learn what you guys are saying. Is there some way I can let you talk? I don't know. Oh boy. Okay. How do I make you appear? I'm sorry, I've never used this. Well, can you at least say stuff? Let's find out. No. Well, I can see that you're watching, but I have no way of getting information from you, which isn't very fun. I can put weird hats on myself. It's not what we're after. Okay. Show or hide the thing. Yeah. Okay. You guys can watch me fiddle with my computer for a little while. I hope it's fun. Okay. Yes. Let's send that picture. One moment. All right. La la la. Hello, viewers. Okay. Okay, I found a Q&A button, and it says this feature is disabled. I want to enable it. So lame. Okay. Chat button. The chat button in the top left. See if you can chat in it. Users. The only member. This is so lame. Oh. Okay. All right, I have a new plan. Maybe I need to specially invite you guys. Okay. So now it's telling me I'm the only member. Ah, boy. All right. Well, maybe I should have had one of you guys be a guinea pig first. Okay. Well,
Wait, ice computer.
okay. Oh, that's fun. We did it. All right, send some other link. So whoever uses that link can actually talk. Cool. Okay, let's try this. And then there's people watching us weirdly. Everybody else can just. Okay. So. Oh, and I can turn off your sound and so forth if I so choose. Okay. Well, then what do we got? I saw that you posted some questions. Okay. Heapification. So the first question that Nick posted earlier, and if you want to butt in with thoughts, feel free to, those who have made sound. So why is heapification as opposed to n? So the reason is that if you just insert stuff, yes, it is in log n, but you can actually do it in just linear time. And you can do that using that trick from the last midterm, which said start with an array and then just sync things repeatedly, or sync things from the bottom over and over. So there is a way to do it. It's just you have to be a little clever. So that's one thing. I don't know. Sensible? Does that seem familiar? All right, he's shy, Nick. Yeah, politely not microphoning. Okay, so that's why that is the case. Yeah, I guess I'll field questions if you want to say them out loud, or I guess I'll read them off the Piazza thread since I didn't set up the Q&A. Ah, it's you, Nick, but that sound's coming out of Ross's face. That's weird. Okay. So, okay, the next one is changing bottom over and over. So there is a way. Got it. So changing edge weights, does that affect the shortest paths tree? Sensible. Well, I can't. It's amateur hour over here, but yeah. If you want to say them out loud, that's why that is. Oh, I hear echoing. Hold on. Yeah, I guess I'll field questions if you want to say them out loud, or I guess I'll read them off the Piazza. It didn't set up the Q&A. Right. Yeah, it's you, Nick, but that sound's coming out of Ross's. Wow, someone's on a real long delay. Okay, I'm forcibly muting you guys. Sorry. Yeah, I don't know what I'm doing. We'll figure it out someday. Okay, so the other one was shortest paths trees. So I think the channel of information is I'm going to grab things from Piazza, by the way. So shortest paths trees. If you increase edges, does it change the shortest paths tree? So in that case, I'm going to say that yes, you can run into trouble because some edges are going to be used multiple times. In an ideal universe, I would whiteboard this thing. But yeah, if you increase all the edges, what that means is that paths that used to be maybe 10 edges long, if you increase all the edge weights by 100, now that whole path is 1,000 longer. So shorter paths would be privileged. So yeah, you can screw up your paths by edge weight changes by everybody. Okay, so that's that one. Okay, then we have this one about bit questions. This is real weird, talking to people, but they can't quite hear me or whatever. I don't know what's going on. I'm never going to be on TV like this. Yeah, so bit questions. How does one approach them? The two bit questions that Nick posted, one of them was this one from the final, which involved powers of 16 and so forth. And I think that one really revolves careful thought, and it really doesn't lend itself well to guess and check. I think it boils down to when you multiply two things that are powers of something, you want to add the powers. That's, I guess, one of the key insights there. And then do rollover. I guess that's not really a general approach so much, though, except to say that, yeah, you can't really just guess and check some type of things like that. All right, not the best answer. All right. This is hard. Okay. Okay. Let's see. Okay, so next I got, so Garrett, as you asked, how is this going to work logistically? I guess not super well.
Our audio is off. Yours, I think yours is lagging by a bit. Huh?
Yeah, mine may be
No,
lagging.
because if you use the other link, you can do voice.
Oh, like actually.
If I do what? I can hear you, because I didn't mute you, because you weren't lagging. Okay. Okay. This is a difficult experiment. So all right. What is next? All right. Well, we have this 2007 question, which is about the difference between iterative deepening and breadth-first search. Okay. In the best case for iterative deepening, if we visit endnodes, I'm gonna have to read that question later because I don't quite follow what it means. Okay. Yeah. All right. I need better questions. Help. Post on Piazza. Okay. Actually, as an experiment, someone who's muted, can you unmute yourself? I'm gonna unmute you.
Hello.
Lisa.
I tried unmuting myself.
Hello. Okay, cool.
Yeah. Hey.
All right.
I think it works. I think it's just a problem when there are like 10 people
Exactly.
talking and talking like at the same time.
Yes. Okay. Cool. Okay. Well, yeah. Someone jump in. Ask something, I guess.
Huh. Are we supposed to be able to convert 2-4 trees into red-black trees? And are red-black trees unique? They're not, right?
They're not unique. Yeah, it's true.
Okay, great.
And I think being able to know, knowing the isometry is certainly fair game, right? Like the idea that before node, you should be able to turn one of those into a cluster of red-black nodes and vice versa.
Yeah. I think my question was more if they're unique or not. They are not unique.
They're not unique, yeah.
Okay.
Yeah. All right.
What else? Like a question about not just like class material, but are you gonna somehow like curve the exams within the different exam groups, or are they not? Like, is there not going to be any difference? Because you know they're going to be different questions and they're going to be at different times and so on.
The questions will be close, though, to the point where we don't think that the curving thing isn't necessary. I want to hope nobody cheats. There may be secret countermeasures that are mean.
Yeah, because you know people might hear things about questions and people might have 3 days more to prepare.
Yeah, I know. Well, I try to make the finals all the same, but there may be sneaky countermeasures. So I don't know. Just throwing on it.
Cool.
Do we need to know about compression and like the last 2 lectures?
Oh yeah.
I think having a vague awareness of what they are is good, but you know, if you haven't had homework on something, a voice appeared. How long does it take to compute the kth largest element of an arbitrary binary search tree? Okay, that's a hard one. I remember someone asking that one in lecture at some point. So yeah, I'll get to that in a minute. But then when it comes to the last couple lectures, awareness. You don't have to have done a bunch of problems, right? I'm not going to give you like, tell me the optimum Huffman code for the sequence of data. That will not happen.
Okay.
Yeah. Yeah. Okay. Kth largest element in the binary search tree, where you just have like a straight up binary search tree. What's the good way to do that? I think I'm actually gonna punt to have to think about that one because I don't want to waste 18 people's time while I try and figure it out again. So I'll take a different question. But I'm gonna add it to the hard question. So this data structure I really like that makes it easy, but I don't remember how to do it on the vanilla one, and I can't figure it out right now. All right, jump in. If anybody wants.
What's the data structure you like for that?
An order statistics tree. So what you do is inside every node you keep the number of children it has, and that makes it easy to walk the graph and figure out where to go. So the root, for example, would have the size inside of it, and the left and the right would know how big their subsizes are. It's a good one. It's good chewing over there. By the way.
What is the difference between radix sort and counting sort?
Difference between?
Between radix and counting sort, bucket sort, I think. I don't know.
Do it using counting sort. So counting sort is you have some finite alphabet, maybe like the digits from 1 to 9 or alphabetical characters or whatever. And you just count how many of them there are. Hearts, spades, diamonds, those kind of things. So anytime you have a finite alphabet, you can do counting sort in linear time. And then radix sort is a way of leveraging counting sort and getting things in order. But you can actually do radix sort by merge sorting, for example, on every digit. So you could start from the rightmost digit, merge sort only on that digit, and repeat it over and over. It's just that we used it as a way to make counting sort work on non-finite alphabets.
Okay. Okay.
Yeah. So they're buddies, but they're not inseparable. I like that Nick and Ross, they're in a frozen posture on my computer. It's like, oh, they're moving again. Yeah. Okay. Next. Yeah, that's more out loud. Man, we can make this work someday. This could be really cool. All right, no sounds and no voices, and no writing. Okay. Yeah, all right, I'm ready. How about Miss
Okay.
JP? Oh, yeah.
I think I'm okay. So, for dynamic programming, right? What is the difference between just memoization and dynamic programming?
There is barely a difference. I think that let's see, memoization, I guess, is a tool for dynamic programming, in the sense that it makes it very easy to take big problems and record the results of the small problems by memoizing. I think if you ask most people, they would probably say that part of dynamic programming is in such an order that you don't have to have an if statement. If you remember in the dynamic programming lecture, there's the recursive approach versus a bottom-up approach. I think some people kind of insist that the bottom-up version is real dynamic programming, but I'm of the mind that both of them count. So
Okay.
I would say dynamic programming, as far as 61B is concerned, is basically memoization.
Okay. I feel like I had one more question on that, but.
Like, what do you record and where and how?
What? What? It's lagging a lot.
Oh no, I'm lagging.
Yeah.
That's not good. Well, my bad laptop is not. I don't know. Okay. Internet. Yeah. I'll talk slower, just in case. So dynamic programming, the hard part is often figuring out what problems to break things into, and where to store it, and what to store. Yeah.
So far,
Yeah.
we've pretty much only used arrays, right? Either 1D
Yeah.
or 2D. Is it ever relevant to do it in like a hash map or anything like that?
I can imagine so. Yeah, if you imagine maybe having taking. That's an interesting one. When would you do that? It'd be. There's got to be cases. You imagine you
Yeah.
have. Yeah, I don't know of any though off the top of my head,
Mm.
but it'd be cute. I mean, one case is if you wanted to do something kind of like array memoization, but you had very sparse indices for some reason,
Mm-hmm.
then you'd probably use that. That's the most likely situation.
Yeah.
Yeah.
I guess also maybe if you were working with numbers that were not indices, so far we've been talking about, or like not that were not integers. So far, like we've always been able to use them as indices in our arrays, but like if you had like 1.2 and 1.6 and 1.8 and so on, for some reason you couldn't. Well, yeah, okay.
Yeah, that makes sense. Yeah, you had to break things down like in the real numbers somehow. Yeah.
Yeah.
Okay.
Mm-hmm.
The hexadecimal number system. I think it's a very good idea to know hexadecimal. It's just a nice thing to know. It's not so bad. Yeah. Like basically what it means to know hexadecimal is you could take a binary number and make it hexadecimal. That would be good. Someone has used Google Effects. I'll use Google Effects. All right. Well, I'm going to be using Google Effects while someone else thinks of a question. Maybe I shouldn't. All right. Downloading an app.
Actually, I have a question.
Yes.
So what's the difference between, there was a question on one of the practice midterms that was, it was like insertion sort, but like backwards. How is that different than heap sort?
Insertion sort, but backwards.
Yeah, it was like, it was like you put the largest item at the end, and then you just, yeah, so isn't that what heap sort is though, too?
Well, I see. With insertion sort, though, the difference is that you're doing these pairwise swaps, or maybe half swaps, where the invariant. I think I would think about it in terms of the invariants are really different. Because with insertion sort, what that would mean is you would have on the right side of the line, like the fixed line, things that were fixed. You would have things to the right are in order, and things to the left are not yet examined, right? So insertion sort, the things that are to the left are not yet examined, whereas in heap sort, the things to the left of the line are heap ordered. So that's the fundamental difference, just like what's on each side of the line. So you're right that the right side of the line is exactly the same, but the left side's very different.
Okay, gotcha. Okay,
yeah.
Cool.
And the reason it matters is that it's very easy to get something from the heap side of the line to the right spot on the right, whereas with insertion sort, it's a little harder.
Okay, cool.
Yeah, that was a cool question. I like that one. I'm not allowed to put goofy hats on myself, apparently. Oh well. Okay. I failed a couple more. Nope, looking at each other. Oh, you got a mustache now, though, Ross. That's good. Yeah. Okay, refresh the Piazza bread. Someone but Sim. Oh, all right. Anybody else got a thing? I see a caret symbol. That's good. Ask questions. Yeah, so that's a really interesting question. How would you generally do them? I don't know. Do more, I guess? That's a really hard question. Yeah, let's see. I think it's a comfort level thing, though. Just at some point, you get more comfortable understanding what the primitives are. Like, what can you actually accomplish? Yeah. So otherwise, I think it is just a bit of fumbling. I don't think we'll be too mean to you, though. I mean, the one with the arithmetic, hard. And powers of 16. I found that one pretty hard. Bit operations and industry. If you're doing low-level stuff, yeah, but otherwise, no. I don't know. Probably a lot of people don't really think about it. Like, if you're doing like web stuff, yeah, chances are you're just abstracting everything away into libraries. Yeah, but 61B is about the guts. So, yeah. It's a mix. It's all of us. Actually, we had a funny meeting earlier today where me and the TAs were, Paul kept saying, these are too hard. And we're like, if only the students could hear you saying this repeatedly, Paul. So the TAs were like, this is too easy. So, yeah. Yeah, it's a mix. All of us chipped in. I think I wrote the meanest question, maybe. Sorry. All right, more. So quiet. Okay, we got Smiley. Yeah, okay. Well, reasonable experiment. Not the best office hours, but we tried. I want to pursue this format later. Was the last part? No, I think it's the last part. Probably not, because we haven't done homework. Like, it's my philosophy that I don't like giving problems on that you've never done anything with. So we would not go deep in a garbage collection, LZW, Git. It's just, yeah, you guys had a lot on your plate. I'd rather not have you having to dig through all of that and really get it. Otherwise, I would have given you homework that was required. So, yeah. Yeah. So I'd say the last part probably will not be weighted more. I mean, it'll probably be, it's not going to be basic Java stuff. That'd be a little silly. Like, it won't be the very beginning of the class. No, on average. Okay, well, so I have 2 letters of recommendation I have to write, so I guess I want to go do those. Oh, wait, sorry. The best advice for tomorrow is sleep well, because you probably don't need things to cram things into your brain. And the other question you just had on the right was what? A suggestion for how to do this better. Can you make it appear again? Separate into something and something.
Separate user in the chat.
Okay, got it. Okay, well, yeah, this was really just let's just see how it goes. So, yeah, it was a reasonable experiment. That's why I kept it short, because I was like, I don't have faith in the process. It was inspired by doing a Google Hangout, because I'm in Brooklyn right now. Yeah, so, there's that. So I won't be there tomorrow. Sorry. I'll be there in spirit. I know. Well, I'll be around. Okay, well, good luck. Sleep well. That's my main advice. Like, it's always good to sleep. What are you really going to cram into your brains at this point? Unless you really need to learn some fundamental stuff you missed, then hey, yeah, that's always what I do. Okay, let's call it a day. Thanks for trying this out with me, guys.
Thank you.
Thanks.
Cool experiment. All right, I'll just leave it on. You can watch me work on some letters right here. Actually, don't do that. I'm okay off. That'd be insane.
Thanks, Josh.
Thanks.
Bye.
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 Was that a wait? Or was it bye? Bye.